So today is all about inverse functions. So you've got notes printed in front of you. I'm just going to kind of read through, but we'll write some extra stuff down as we go through. So an inverse function undoes the operation. And when you think about inverse, think about opposite. Okay, so in math, inverse is the opposite function. The x's and y's switch, and if you switch the x's and y's, you end up switching the domain and the range, because remember, domain is all about x and range is all about y. All the operations switch. So addition would go to, and multiplication to. Very good. And then if you looked at the graph gets reflected along that line, y equals x. And this brings up some stuff that we did in math too, and you guys did in middle school when we did transformations. You don't have to write this part down. But remember when we did our transformations with our x, y, and we said if we reflected over the line y equals x, then the y and the x switch places. And so that's what happens with inverses. That's when we had all those points, those coordinate points that we plotted in the shape. A lot of times it was a triangle, and it got reflected. But that's kind of how it relates to what we were doing in math too. So when we look at these parabolas here, f of x on my paper, it's this blue normal looking parabola. And let's talk about how we can find the domain, range, and determine if it's a function. So what is the domain of this parabola? Now when you think about a picture, domain is your x values, right? And the x-axis goes left and right. So if we draw out a parabola, as we go up, the parabola gets wider. So what x values does it cover? All of them. Good. So your domain for a parabola is all real numbers. Now, is the range all real numbers? No, because range is how far the graph goes up and down. What y values does it cover? Well, this particular parabola has a starting point, right? And then it's graphed above. Where do you think the starting point is? 0. So for our range, we would say y is greater than or equal to 0, because it starts at that x-axis and everything is graphed above. Now, to determine if something is a function, for this question, we're just going to say yes or no. But to determine, we use the vertical line test. You've probably heard about it before, definitely in Math 1. But the vertical line test says if a vertical line crosses a graph more than once, it is not a function. If a vertical line crosses a graph more than once, it is not a function. And that's any little vertical line that you could have. So a lot of times I tell people to take their pencil and lay it down on the graph and kind of go through and see how many times it hits that graph. But remember, with a parabola, as it goes out, it gets wider. So if I took a random vertical line and just placed it here, 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 and kept going, how many times does it touch that graph? Each vertical line only touches once. So is it a function? Yes, it is. Correct. Now, we are going to take that function and find the inverse of it. So if you find the inverse, you reflect over the line y equals x. So for parabolas, they get twisted onto their side. When we switch the x and y values, it reflects over this dotted line y equals x. So now we have f inverse. And you might see this little -1 power right here. That -1 is called the inverse. So anything to a -1 power. So what happens with the inverse function? So now let's think about the domain of this red graph, this inverse. Well, if the parabola is laying on its side now, does it go everywhere left and right? No, it has a starting point and then just goes to the right. Well, when you go to the right, we think about values that are positive or greater, right? So where's the starting point for this parabola? It starts at an x value of 0. If I start kind of right here, it looks like it starts about at 0. Now, range is how far the graph goes up and down. Remember, parabola we said gets wider as it goes up. So if it's laying on its side, it's still going to get wider, which means it's going to cover all the numbers because it's going to keep going up and out. So notice here, and it says it up here, the domain and the range switch. The domain of the original function is equal to the range of the inverse. And then the range of the original function is the same as the domain of the inverse. You just also have to switch x and y because domain is only about x and range is only about y. Now, Sarah already answered this question, but is this graph a function? No, it is not, because if I put a vertical line right here, it hits the graph twice. And if it hits more than once, we say no. So what we're going to look at next is we're going to look at 4 different types of functions or 4 different types of looks at functions. And we're going to determine the domain and the range of the original, domain and range of the inverse, and then decide if that is a function or not. So go to the right on your paper, and we're going to look at the first one, which is a table that we have. And it's going to take mine a second to pull that up. Now, with a table of values, those are just points that you have. So they are not, it's not a whole function. So when you see a table, like the one that will show up after my board decides to unfreeze, you just see 4 values there in your table. You can plot those points if you want to, but you actually don't have to. I'll show you how to solve the problem without having to plot the points. And we're giving a second. There it goes. Okay, so when we talk about domain, domain refers to what values? X values, okay? So here we have just 4 X values that are listed. That's your only X values that you have because these are like 4 coordinate points. So when you state your domain, you just put your X values in curly brackets from least to greatest, but do not put any repeats. So your domain for this would be -1, 0, 1, and then close your curly bracket. So make yourself a note. List least to greatest. Do not repeat. So that's how we figure out our domain. We list them least to greatest, but don't repeat. Guess what we do for range? Same thing, but do the y's. So what do I list for our range? 1, 2, 3, 4. So list from least to greatest. Don't put any repeats. Now, to determine if it's a function, we want to see if it passes the vertical line test. So for this particular problem, I am going to graph it just to show you what it looks like for our vertical line test. So I'm just going to graph it real quick there on the notes, and you guys can do that too. You don't have to grab graph paper. We're just keeping it simple. I'm going to graph my points in purple so that way we can see them a little bit better. So -1, 1, 0, 2, 1, 3, and 1, 4. So there's my 4 points. Now, we check to see if it passes the vertical line test. Carter, you're already saying no. Why not? 2 points have the same X value, right? If I put a vertical line right here, it's going to hit both of those points. So is it a function? No. And one quick a quick way that you can tell is that you can look at your x values. If x repeats, it is not a function. Because it would not pass that vertical line test. So that's a quick way. So do you have to graph it and test it with a vertical line test? No, just look at your x values. If the x values repeat, it is not a function. Now, part D wants us to find the inverse. Well, what does the inverse do with your x's and y values? It switches them. So what we're going to do is we're going to make a new table with x and y, still keep x and y in the same spot, but switch all the numbers. So now my new x values are, and my y values are. Good. And that's how we figure out a new table for this function. So now there is the inverse. Now we answer these 3 questions about the inverse. So we're going to be using this table to answer those 3 questions. So with this table, what is the domain? 1, 2, 3, 4. In order, curly brackets, no repeats. What is my range? -1, 0, 1 in the curly brackets, no repeats. Is it a function? Yes, the inverse is now a function because that's right, and all our x values are different. It would pass the vertical line test, but all of our x values are different, so it is a function. Now, tables, they're pretty easy, right? But a lot of people get them wrong because they forget how to do tables. But they're the easiest ones. So remember, you list them out, you switch the x and y, and look at the x values to determine if it's a function. If the x values are all different, say yes. If not, say no. All right, let's look at our next one. Y equals 3/4 x plus 2. Well, what kind of equation is this? It's linear, right? If we graphed it, it would make a what? A straight line. Linears all typically work the same way. So they're going to make a line. Now, if you have a line, what's the domain of any line? All real numbers. That's exactly right. It's going to go on forever in all of our directions, so it's all real numbers. What about our range? All real numbers again. Is it a function? Would it pass my vertical line test? Yes. Now let's find the inverse of this. So we said if we had a table, we switch the x and y values in the table. Here we don't have a table, we have an equation, but we still do the same thing. We switch x and y. So it's x equals 3/4 y plus 2. Now once we switch that x and y, what should we also do? Have you seen an equation like that starts with x equals? Our equations typically start with what? Y equals. So let's solve this equation for y. Okay, what would you do to get y by itself? Subtract 2. Now keep it how it looks. So over here it's going to be x minus 2 equals 3/4 y. Okay? Now we want to get rid of that fraction. You can get rid of your fraction in 2 steps instead of doing 1 step, which probably is going to be easier for us. First, get rid of the 4. How could I get rid of the 4? Multiply by 4. Since everything is kind of being divided by 4 on this side, we could multiply both sides by 4. But when you multiply the left side by 4, you have to distribute. So we get 4x minus 8 equals 3y. Now, what would you do to get y by itself? Divide by 3. And if you divide one thing by 3, you have to divide all of it by 3. So we end up with 4/3 x minus 8/3 equals y. Now, I have seen some people, and I want to tell you, do not do this. They get to this step here and they say, okay, I'm going to divide everything by 3/4, and they leave their answer like this. Have you seen a fraction inside of a fraction? No. So don't do it this way. Just split it up into 2 steps. Multiply everything by 4, divide everything by 3. Now, no matter what I just did, I ended up with this function here. What kind of function is this one? If you were to graph it, what would it look like? It would still be linear. It'd still be a line, right? Remember what we talked about on that first slide when we had our graphs? We reflected over the line y equals x. Well, if you take a line and you reflect it, it's still a line, right? So we still have a linear equation here that we're dealing with. So that linear equation, we're going to figure out our domain and range. So what's the domain of any linear equation? And what's the range? Is it a function? Yes. So let me give you some advice here. Anytime you see a linear equation, there are 6 things that are always the same. Domain. Yep. For both pieces. The domain and range are always all real numbers for linear and its inverse. And it is always a function. Its inverse is always a function. Those are things that are always the same. So if you see a linear problem on tonight's homework, you have 6 answers done. The only one you have to worry about is doing the math to actually find the inverse equation. Switch x and y and solve for y. All right, let's look at our next one on our list. What kind of equation do we have here? No. Quadratic. That is the answer. That one is a quadratic. And when in doubt, you can always graph it to see what it looks like. Okay, so, and it might be a good idea to graph this one anyway because that's going to help with our domain and range. So let's grab those calculators. Let's type this in y equals. And let's look at the graph. All right, so there's my graph. So think about your parabola. Think about domain as how far the graph goes left and right. So what would be the domain of this graph? All real numbers. Good. Is the range all real numbers? No, because we have a starting point, right? We have a minimum. Let's find that minimum. You can hit second trace and option 3. So second trace 3. And then remember your calculator asks questions. The left, the right, and enter on guess. So move your cursor to the left, hit enter. Move your cursor to the right, hit enter, and enter on guess. Now, when we talk about range, what value do we look at? The y value. So our y minimum is at -1. So how can we use that to describe our range? Very good. That's right. So find that minimum. Now, if that parabola, because sometimes the parabola doesn't always open up, sometimes it opens down. If your parabola opened down, you wouldn't be finding the minimum, you would be finding the max. And your range would go from greater than to less than. So keep that in mind. So is your parabola a function? Yes, because it passes the vertical line test. Now, you can actually pause here and not do part D and actually answer parts E, F, and G. Because what do we know about the domain and the range? They switch. So whatever we put for domain is going to go for range. So my range is, and whatever we put for range is going to go for domain. So my domain is, no, keep everything the same, just switch the value. So X is, good. So remember, domain is talking about X, range is talking about Y, so you just replace that part and you've got it. So you're just flip-flopping those. Now, remember what we talked about with parabolas. So parabolas open up, but then the inverse would open sideways. So is it a function? No. Okay, very good. All right, so now let's do the inverse. Don't flip it over yet because we didn't answer part D. Don't forget. So with the inverse, just like the linear one, we switch X and Y and solve for Y. Remember, f of X is a fancy way of saying Y equals. So if I flip these, it's going to be X equals Y plus 1 squared minus 1. Now, you want to solve for Y. Remember, when you're solving, you do your PEMDAS in reverse when we solve. So we're going to start with any add or subtract. So first we're going to add the 1 to both sides. Good. So we get X plus 1 equals Y plus 1 squared. Now, you're basically starting on the outside and working your way in. So on the right side, the outside thing is your exponent. How do I get rid of the squared? Square root. So I'm going to square root both sides. And what do you have to put with your answer when you square root? So this is plus or minus the square root of X plus 1. And then the parentheses drop and the squared drops. And what's the last thing we do to get Y by itself? Subtract 1. Now, remember what we did with plus or minus before. Where should that 1 go? In front of the plus or minus. You're exactly right. We cannot subtract 1 inside this square root because they're not both under a square root. So we just tack it in the front. Negative 1 plus or minus square root X plus 1. And that would get Y by itself. So what the plus or minus does, it actually makes the two parts of the parabola. So if you were to graph this, you would have to type in both of these to see the graph. But that's what puts it on its side. So that way you have that equation. Now, if you have a quadratic, there are certain things that are always the same. So let's highlight those that are always the same. If you see a quadratic function, there are 4 things now that are always the same. What do you think those 4 things are? Domain of the first and the range of the inverse. Yep, those 2 are always all real numbers. And there's 2 more things that are always the same answer. Now that can switch depending on the numbers. Not every graph will have negative 1. Almost is what type of, not line, but function it is. So part C and G will always be yes for C and G will always be no. Because with a parabola, it's always a function, right? But when you do the inverse, it lays on its side. So is that a function? No. So domain, all real numbers. Is it a function? Yes. Then with the inverse, the range is all real numbers. Is the inverse a function? No. All right, now flip over to the back, and we will look at one more type of problem that we have, which is a square root problem. Now, we graphed these back in Math 2, but it's been a while, so you've probably forgotten what they looked like. So to start out, let's just graph this one. make sure that you right arrow, oops, come on now, to get out from under the square root and then put that plus 2 at the end. So make sure just 3x minus 4 is under the square root or in parentheses. And then hit graph. What kind of shape does that make? It's like a curve. Yeah, it's just like a curve. And that's what square roots make. So when you see these square root functions, they are going to make that curve shape. So they're going to have a starting point and they're going to go up and over, or you might have a starting point and they go down and over if they start as a negative. So what we have to do is find that starting point. Some people say that square root looks like half of a parabola, and you would be correct. It might be that top half or that bottom half, but it's the part laying on its side. Okay? So let's figure out, how do we find this starting point right here? This is going to be an x, y value. Now, there are two ways to find it. Unfortunately, your calculator may not give you the correct answer. So you got to be careful with using our calculator, because if you go back through and try to find this minimum point that's here, the starting point, your calculator might give you an error message. The newer calculators might find it, but the old ones may not. So here's the way to do it by hand. To get the x value, you're going to use what's under the square root, and that's going to help you find your x value. What do you think I'm going to do with the stuff under the square root? Set it equal to 0. You're exactly right. So I'm going to take 3x minus 4, set it equal to 0, and solve. So what would I do to solve? Add the 4 and divide by the 3. So x equals 4/3. That's going to be your starting x value. Now to get your y values, you look for like a translation. Y is just how far it moves up or down. And you can tell that by, you could plug in what you get for x, but you could just look at the outside number. Our outside number is what? 2. So my starting point is 4/3 and 2. Now again, I'm going to try to find it on my calculator, so it would be, in this case, a minimum value. But when it asks you to go to the left, it doesn't actually have any y value, so it's not quite sure where to start. But if you pick somewhere to the left and then somewhere to the right, it gives you that error message because it doesn't have any data to go with. So to find your start value on these, just do it by hand. Take what's under the square root, set it equal to 0. That will give you your x. What's outside will give you the y. Now, when we review for the EOC, you guys can use Desmos, and you can kind of drag your cursor, and it will find that start point for you on Desmos. Unfortunately, our calculators just won't do it for us, so just do it by hand. All right, so we have our start point. The graph goes up and over, so let's talk about domain. What would the domain of this problem be? Now, domain is how far the graph goes left and right. We have a starting point, right? What's our starting x value? 4/3. Now, where does the graph go with the 4/3? Goes to the right, which is what symbol? Greater than or equal to. That's right. So we're starting at x at 4/3, and we go to the right, which would be greater than or equal to. Now, you can pause here, and you can actually go over here and use that to write your, oops, about missed it, range. Sorry about my curve there. So the range would be y is greater than or equal to 4/3. Now let's go back and look at our original range. So range deals with the y value of 2. So y is related how to 2? Well, I'm going up and over, so it would be greater than or equal to 2. Which brings me to my domain would be x is greater than or equal to 2. So remember, domain and range flip because your x's and y's flip. So now we have this next question. Is it a function? Yes, it is a function because it will pass the vertical line test. It would be, because remember, if we look at half of that parabola like we did on the front, it's going to flip the other way, which means it's going to flip and open up. So it is also a function. So the last thing we want to do is find our inverse, same way we did the last two. Switch x and y, and then solve for y. So it's x equals square root 3y minus 4 plus 2. So what am I going to do first? Subtract 2 on both sides. Very good. So x minus 2 equals the square root of 3y minus 4. You would have to square both sides. Now on the right side, you're squaring the whole parenthesis, and it is okay to leave it as a parenthesis like this. It's okay to say x minus 2 squared. You don't have to write it twice and FOIL it out, but you cannot square each term. So remember, you can't square over addition or subtraction. You can't share that squared. You have to leave it in parentheses and then put a squared. Okay. Now what would we do next? Add 4. Now when you add 4, you're just going to add it outside of the parenthesis. And then last step, divide everything by 3. Now, when you divide by 3, you're dividing this whole quantity by 3. And what did we talk about before? Just a little extension. When we said x over 3, what was another way of writing x over 3? Not 3x, 1/3 x, because the x is on the denominator. You could treat it like a number times that. So how can we rewrite this when we have x minus 2 squared over 3? We could put 1/3 at the front, x minus 2 squared plus 4/3. So some math tricks, we've talked about those before, but it's been kind of a while back that we've talked about those different parts. So use your notes as a guide when you do your homework. Now let's talk about things that are the same with square roots. When you look at a square root problem, there are actually only 2 things that are the same when you see that square root. Function questions. Is it a function? Yes. Is the inverse a function? Yes. Everything else depends on that start point. It's not always 4/3 and 2, and it's not going to be the same equation. So you got to figure out that start point, and then you can go through and find everything else. Okay? So most of your homework tonight kind of looks like that, where we're going through those questions. All right, I want you to move to the right side now, and we're going to talk more about inverses. And this is the stuff on your paper that's kind of small, but we're going to answer those 2 questions in just a little bit that are below that problem. I just had to kind of squish them somewhere else. All right, so we are given y equals x plus 5. So part 1 says find f to the negative 1 power. What is it asking us for when you see f to the negative 1 power? The inverse, that's right. So when you see that, think inverse. And how do you find inverse? Swap y and x. And solve for y. So we're going to subtract 5. So x minus 5 equals y. Now, if you wanted to write your functions down as actual functions with the f of x, the original function, f of x, is x plus 5. The inverse function, f to the negative 1 power of x, is what we just solved for, which was x minus 5. See how we talk about the operation switch? The plus goes to minus. And so now we're going to do composition functions like you guys did at the end of the video yesterday that you watched after the quiz. So when you do composition, you start on your inside and you work your way out. So the first number I see is 3. What's right beside the 3? The inverse function. So first we're going to take 3 and plug it into our inverse function. So what is the inverse function of 3? So we're plugging 3 into this bottom equation. So it'd be 3 minus 5, which makes -2. Now we take that answer and we replace it here with all of this. So we're going to take that answer and plug it into function f. So now we're going to do f of 2. -2. Sorry, my bad. And so we're going to plug -2 into the top equation. So what is -2 plus 5? 3. And that would be our final answer. All right, let's do our next problem. F inverse of f of 3. So let's first start with f of 3 because it's on the inside. So we're going to take 3 and plug it into the original function. 3 plus 5 makes 8. Then we're going to take our 8 and plug it into the inverse because that's on the outside. So what's the inverse of 8? Well, that's 8 minus 5, which is 3. This is kind of getting interesting. Does anybody see anything that's kind of interesting about these two problems? Our final answer is 3. And what did we originally plug in? 3. Now, notice in this one, we plugged it into the inverse, and then we plugged it into the function. What is the inverse? How is the inverse related to the function? It's the opposite. It's kind of like when you square something and then square root something. What happens when you square something and then square root something? It goes back to the original, right? So when I do the inverse of the function and then the function or vice versa, it goes back to the original. So do I even have to show work for these next two problems? What's the f? Oh, should have a -1 in there, and -1 kind of went away. That should be a -1. All right, so what is the function of the inverse of 100? 100. Boom. Done. What is the inverse of the function of -50? -50. Boom. Done. When you plug something into the function and then plug it into the inverse, it just does the opposite. So you're doing something and then doing the opposite. You're going back to the original. So no matter which one you do, it's going to give you that back. All right, let's look at our next info. So this is a key piece of information. So you guys might want to highlight this or put a little star by this, whichever one that you want to do here. If f of g of x equals x and g of x equals x, then the functions are inverses of each other. This is a way to prove that two functions are inverses of each other. So if you can do f of g of x and get out just a singular x, or g of f of x and get out a singular x, then those two are inverses of each other, and you know what the inverse is. So let's try it out with this problem. Let's start with f of g of x. This is a good review of what you guys learned yesterday. So what's in the middle? G. So we're going to take function g and put it into function f. So we're taking function g and we're going to put it into x. They're going to replace. So if I replace I have 3 and then parentheses, and I'm going to put g of x in that parenthesis, which was 1/3 x. Well, what is 3 times 1/3 x? X. And that's our first thing that we want to check. Check f of g of x equals x. Now we also need to check the other way. So now we're going to check g of f of x and see if that also gives us x. So both of those things have to be true for them to be inverses of each other. Now what's in the middle? F of x. So now we're going to go backwards. We're going to take what f of x is, which is 3x, and we're going to replace it with this x and our g of x equation. So whatever's on the outside is what is you're going to use, okay? So this is 1/3 times x. Well, now x is the whole function, which is 3x. So what's 1/3 times 3x? 1x. So are they inverses of each other? Yes, because f of x, or f of g of x, and g of f of x both equal x. It's a lot of x's in there. Let's try our next example. We're going to do the same thing. We're going to find f of g of x and g of f of x. But in this case, they're called j and k. You're just going to put both of them together. So let's start with our first one. I'm going to do j of k of x. So start on the inside. What's on the inside? K. So I'm going to take the whole function k and plug it into function j. So I'm going to take all of this and put it where that x is. So j says 3x minus 1. So if you want to write it with just parentheses, that's our outside function, 3 parentheses minus 1. And inside those parentheses, we're plugging in the other function. So what's the other function? 1/3 x plus 1. And now we simplify to see if we get just x by itself. So what would I do? Distribute the 3. Good. So what's 1/3 times 3? X. And then what's 3 times 1? And then I have a minus 1 here at the end. So if I combine my like terms, I get x plus 2. Does that match what it's supposed to? What's it supposed to equal? Just x by itself. That's right. Up here it says f of g of x should just equal x. So if you plug one function into the other, we should just get out x. Did I just get out x by itself? No. So are they inverses of each other? No. You don't even have to check the other one. You can just stop right here because that doesn't work, and you can say no. So plug one into the other. If it equals x, then take the other and plug it into the first one and just check to make sure they work. All right, let's talk about 2 more things. So here we have, which of the following graphs have an inverse that is a function? That's what it's asking for. So these are the original graphs. We want to check to see if their inverse is also a function. So we use something called the horizontal line test. So what did the vertical line test say? If it hits only one time, it is a function. If it hits more than once, it is not a function. So this one's the same way, except we talk about the inverse being a function. So you would say, if a horizontal line hits a graph more than once, the inverse is not a function. If a horizontal line hits a graph more than once, then the inverse is not a function. Now, we already know the answer to the first graph there, because the first graph is what shape? It's a parabola, right? Now, a parabola is a function, but is the inverse a function? No, because it ends up going on its side and it doesn't pass the vertical line test. So what you can use in place of the vertical line test is the horizontal line test, and that will tell us if the inverse is a function or not. So if I take any horizontal line and put it through this graph, it hits my graph more than once, so this one is a no. The inverse is not a function. Now, what about for B? No, it looks like it hits multiple times right in here, but we can't really tell because it's kind of small. But yeah, it looks like it kind of goes up a little and then goes down a little bit. This one is kind of tricky. Some people say no and some people say yes. I'd actually take either one for this one because the graph isn't quite clear. But if we look at how it kind of levels off and then goes a little bit, there might be a little bit of increase in there. So I would probably say no, just because that's so close it's hard to tell. But what about C? Yes. And that looks like our square root functions, right? Okay. What about D? If I put in vertical lines in here, does it cross more than once? Only crosses one time to me, so that one would be a yes as well. What about a vertical lines for E? What about F? Definitely no, right? What about G? Nope, just like our parabola. And then what about H? Yeah, if we look just along the x-axis, it hits 3 times. So with your horizontal line, make sure it only crosses once to be to have an inverse to have an inverse as a function. Sorry, I forgot what I was saying. All right, last 2 questions. I know they're kind of stuffed up there in the middle. I kind of put these out of order and didn't mean to. But let's look at this first question. What is the possible domain of the inverse of this function? So we are looking for the domain of the inverse, which is the same as the what? So if we can find the range of the original, we can tell the domain of the inverse. And how do we figure out the range of that equation? Yeah, let's look at the graph, right? So everybody grab those calculators. Let's type it in. So y equals 3x squared minus 18x plus 5. And then hit graph. It's another good review for the exam because can we see the graph? No. We do know it should make what kind of shape? A parabola. So if we moved our graph, which direction would we be able to see that parabola? Down, right? We need to move it down to see that U shape at the bottom. So go to window and just change the one that's going to move it down. Is that X or Y that's going to move down? Y. And it'd be our Y minimum. Let's make that a bigger number. Or smaller, really. But change negative 10 to maybe negative 30. And then just hit graph. Now do we see that full parabola? Yes. Now what are we trying to find with that parabola? the minimum value, because that's going to help us find our range. So second trace, choose minimum. I'm going to move my cursor a little bit closer to the curve, but stay to the left of the curve. Hit enter. Go to the right of the curve. Hit enter. Enter on guess. And what value am I looking for? The y value. So what is my range for this problem? The range of the original would be y is. So the domain of my inverse, you can just put a d with a -1 power. Domain of the inverse would be. Very good. So that would be the answer that we're looking for. The domain of the inverse is the same as the range of the original. All right, here's our last question. Does an inverse exist for the entire domain of the function x squared plus 7x plus 9? Well, let's talk about what kind of problem that is. If we graphed it, it's a what? It's a parabola, right? So the original function is a parabola. Does the inverse exist? Is the inverse a function for this? No, because it doesn't pass that horizontal line test, right? Because the inverse, it would flip over to its side this way. What could make an inverse exist for this type of graph? If it's laying on its side and only had what? Only had half of it, right? If I took this graph and I cut it in half and I maybe took off this part, would the inverse exist? Yes. So does an inverse exist for the entire domain of this function? No. But if we cut the graph in half, it would. Now, where would we need to cut it in half at? At the middle, at the vertex, right? If we found that vertex and cut it in half there, we would have the graph. So let's actually find that vertex. So let's type this in our calculator and do the same thing again. So go to y equals, type in your x squared plus 7x plus 9. And then you might want to get back to your original window. How do I get back to the original window? Zoom 6. Yep, Zoom 6 gets us back to that original window. So now what am I trying to find here? The middle or the minimum. Move your cursor to the left. Hit enter. Move your cursor to the right. Hit enter. And enter on guess. Now, if I find that middle point, I get -3.5 and -3.25. So that's my middle point right here. -3.5 and -3.25. Now, we're talking about splitting that graph in half and only looking about half of the graph. So our new domain, and we're talking about domain for our original function, what we would need is just half, one way or the other. So we're going to look at the x value. If I only graphed the left part of this graph for x less than or equal to -3.5, the inverse would exist. And you can use either less than or equal to or greater than or equal to for this because you just need half of it. Doesn't matter which half you have, the left side or the right side, the inverse would still exist. Okay, your homework tonight is this worksheet. The front is more of what we just did, but the questions can go real quick if you use your notes. And then the back side is more what we did at the beginning with finding all of the different pieces. I wrote A through G at the top, but you're finding A through G for all of the problems on the back, just like we did our first set of notes that we did. Now, don't forget you have additional homework to do from yesterday, and then tomorrow starts our Thanksgiving break, so no school tomorrow. So you have 2 homework assignments due by Monday. Do not slack off like you did with circles. We only have 2 more tests, 1 quiz, and then about 5 more homeworks. That's it. Okay? So if you need to up your grade, this is your last chance. These 12 days counting today is all we have. Okay? So over Thanksgiving break, yes, enjoy time with your family, eat lots of turkey, take naps, watch some football, watch the parade, whatever you want to do. But a couple of days in that break, make sure your homework gets done and make sure you review all the notes from this unit, your piecewise functions and this inverse stuff. Because when we come back, we're going to review that Monday and test that Tuesday. Okay? All right.